All right, we're going to start a new chapter. This section 9.1, there is a lot of new information. So do the best you can, follow along, and we're going to break it up into two parts. So this is part one. Well, what are you going to learn in this section? Well, you're going to learn, number one, how to use properties of radicals to simplify expressions. You're going to learn how to simplify expressions by rationalizing the denominator and how to perform operations with radicals. So let's start with how we're going to use properties of radicals. A radical expression is an expression that contains a radical, a square root. An expression involving a radical with index n is in simplest form when these three conditions are met. This is important. You are going to learn how to simplify a radical. So no radicands have perfect nth powers as factors other than 1. No radicands contains fractions. That's important. You cannot have the square root of a fraction. Cannot. Because the denominator cannot have a radical in it. And actually, that's what's in the next one. If you have a fraction and the bottom number is a radical or there's any square root in the denominator, it is not simplified. So the property below is going to show you how you can simplify radical expressions involving square roots. And here it is, the product property of square roots. The square root of a product equals the product of the square roots of the factors. All that means is this: if you took the square root of 9 times 5, that is equal to the square root of 9 multiplied by the square root of 5. This is the square root of 9. I then can break it up and get the square root of 9, which is 3, which gives me my final answer of 3 root 5. In algebra terms, you can take the product of two factors and separate them, where a and b both have to be greater than or equal to 0. We're only talking about values that are greater than or equal to 0. So for example, I could take the square root of 20, and I could break it up into the square root of 10 times the square root of 2. I could break it up into the square root of 5 times the square root of 4. I could also break it up into the square root of 1 times the square root of 20, all using this property. But only one of these can be simplified, and here's where we're going with this. I cannot take the square root of 10. I cannot take the square root of 2. Therefore, this cannot be simplified. On the last one, I can take the square root of 1, that's 1. But the square root of 20 is still there, so I'm left to what I have at the beginning. So you're never going to break something up with a factor of 1. But here, the square root of 5, I cannot do anything with. But the square root of 4 I can, because that's a perfect square. That gives me 2. So that would give me the answer 2 root 5. When you're taking the square root of something, you must memorize or know perfect squares: 4, 9, 16, 25, 36, 49, and so on. So these would be the square roots. Now if you do the cube root, a perfect cube, well, let's see, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 125, and so on. You must know these numbers. If you don't, this is going to be difficult. And if you don't know them yet, write them on your paper before you even begin your assignment. So let's start with example number 1. Let's simplify the square root of square root of 108. What you have to do is think of in your mind, what is the biggest perfect square that is a factor of 108? So you can say, does 4 go into 108? Does 9? Does 16? You're going to find out that if you figure it out, that 36 goes into 108. And the factors will be 36 and 3. So I can use the product property of square roots, to break that up into root 36 multiplied by root 3. Root 36 gives me 6, root 3 stays there. And there's your answer. You're done. Now, before we go on to the next one, I want you to think about something else. Now, let's say on 108, you did decide to break it up into 4. And you were thinking, okay, well, I can take 108 and I can divide it by 4. That gives me 27. So I'm going to break this up into square root of 4 multiplied by the square root of 27, which is correct. And the square root of 4 does give you 2. The problem is 2 root 27 is not simplified. It's not simplified. Because what number can you take the square root of that goes into 27? It's 9. So you'd actually have to go one step further, which leads into the next thing. If you have a number outside, 2 multiplied by, and then you break this up into root 9 multiplied by root 3. I now can simplify root 9, which is 3, and that gives me 6 root 3. Now it's more steps, but it still will lead you to the same answer of 6 root 3. Now, in part B. In part B, we have to go back and remember when you multiply with the same base, you add the powers. Pretty easy. When you multiply with the same base, you add powers. Remember that. So, in B, I want to know 9x to the third power. Well, the square root of 9 is 3, so that's easy. But x to the third power. You must have the variable with an even power. If you don't, you must just subtract 1. That's all you do. So x to the third becomes x squared, and then multiplied by root x. Now root x is going to be left alone. The square root of x squared. What times itself gives you x squared? Well, it's x. So this becomes x, and so my final answer is 3x root x. And that'd be my answer. So let's just do another one. If I gave you, let's say, 2, that sounds good, x multiplied by 20x to the fourth, y to the 31st. You have to take this one step at a time. This is not easy. I'm going to simplify the square root of 20. I'm going to simplify the square root of x to the fourth. I'm going to simplify the square root of y to the 31st. The 2x stays there. Root 20 can be broken down into root 4 multiplied by root 5. Why not 10 and 2? Because those are not perfect squares. X to the fourth. It's even. I'm done. The square root of x to the fourth is x squared. Now, this is odd, so I have to subtract 1, so that's going to be the square root of y to the 30th multiplied by the square root of y. This will give me 2x multiplied, the square root of 4 is 2, multiplied by root 5, multiplied by x squared. The square root of y to the 30th is y to the 15th, multiplied by root y. So, the roots, I can use the product property to put them back underneath the square root. So that's going to be the square root of 5y. I cannot simplify that. But everything else gets put together. So I could take 2 times 2. That just gives me 4. X times x squared is x to the third. And y to the 15th. So my answer is 4x cubed, y to the 15th, multiplied by root 5y. Now the next core concept is the quotient property. The quotient property is just like the product property. If I have the square root of 3/4, you can break it up into the square root of 3 divided by the square root of 4. The square root of 4 then becomes 2, and my answer is the square root of 3 divided by 2. You cannot have a root in the bottom. Now I'm going to show you two different ways that you can simplify this. If I gave you the square root of 20/5, I could break that up into the square root of 20 divided by the square root of 5. Don't do that. Here's why. If I can simplify that fraction underneath, then simplify it. 20 divided by 5 is the square root of 4, which becomes 2. You can do that. But if I gave you this, the square root of 5/64, I cannot simplify 5/64. So you would break that up into the square root of 5 divided by the square root of 64, which then becomes root 5 divided by 8. And root 5 is in simplest form. But let's say I gave you this. The square root of, let me think. What do I want to do? Let's do 18. No, let's do 20 again. 20/64. Now I could simplify that into 10/32. I wouldn't though, because 64 is a perfect square. So I would break this up into the square root of 20 divided by the square root of 64. That gives me the square root of 20 divided by the square root of 64, which is 8. But I'm not done, because the square root of 20 has a perfect square in it. So I can break the numerator up into the square root of 4 times the square root of 5. The square root of 4 becomes 2 root 5 divided by 8. I'm still not done. I now have 2/8. I can simplify the fraction 2/8, which gives me 1/4. So my final answer is root 5 divided by 8. Now one last thing, and I'm going to put it up top. If I have this, nope, I don't have that. If I have this, root 5 divided by 10, I cannot simplify that at all. Don't ever do it. If you have something inside a square root and something outside a square root, it cannot be cross-simplified. You cannot simplify that. Example number 2, let's put it to use. The square root of 15/64. Okay, I'm going to break it up into square root of 15 divided by the square root of 64. That would give me the square root of 15 over 8. There is no perfect square that goes into 15, so that would be my answer. The next one, square root of 81 divided by x squared. Square root of 81 gives me 9. The square root of x squared gives me x. 9 divided by x is my answer. You can extend the product and quotient properties of square roots to other radicals such as cube roots. Note that when using these properties of cube roots, the radicands may contain negative numbers, because a negative number times itself 3 times is a negative number. So we now can have negatives. So let's do 3 examples together. Or 4 examples. A, the cube root of negative 128. There is no number times itself 3 times that gives you 128. Now if you wanted to off to the side, put 2 to the 3rd power, that gives me 8. Then 3 to the 3rd power is 27. 4 to the 3rd power is 64. And 125 and so on. So my question is there any one of these that goes in as a factor of negative 128? And absolutely. I can break this up into the cube root of negative 64. Always put the negative with what you're taking out, by the way. Times the cube root of 2. What number times itself 3 times gives you negative 64? That's negative 4. And then cube root 2. There's my answer. Next, the cubed root of 125. Well, that's 5. And then now you only can use multiples of 3. So before it was even numbers, since we were doing square roots. Now it's going to be multiples of 3. 3, 6, 9. So I have to break up x squared, or x to the 7th, into x to the 6th, root x to the 6th, the cubed root of x to the 6th, multiplied by the cubed root of x. What times itself 3 times gives you x to the 6th? And if you don't know, it's this. What to the 3rd power gives you x to the 6th. Easy. It's what you're multiplying by, so it's going to become x squared. And then cubed root of x is left alone. The next one, I break this up. Cubed root of y divided by the cubed root of 216. That would give you the cubed root of y. I can do nothing with that. Over what number times itself 3 times gives you 216? It's 6. There's your answer. Lastly, the cubed root of 8x to the 3rd over the cubed root of 27 y to the 3rd. On the top, I would have to break this up into the cubed root of 8, which is up here, multiplied. Oops, and I just realized that should be a 4 here. I have to have a multiple of 3, so I'm going to break it up into the cubed root of x to the 3rd times the cubed root of x. On the bottom, I don't have to do anything with it because the cubed root of 27 gives me 3. The cubed root of y to the 3rd gives me just y. So that means on the top, I'm going to get 2x cubed root of x all divided by 3y. Nothing here can be simplified. Now, if you had an x and an x on the bottom, or if you had 4/6, then you could simplify this more. But that would be your answer.